Okay, today I want to talk about section 3.1, the maximum and minimum values. So this is outline. So I want to talk about the definition of a maximum and minimum values. Second one, I want to explain how we can find maximum and minimum values geometrically and algebraically. Third one, I want to explain the extreme value theorem and the Fermat theorem. The first one, I want to talk about the critical numbers. The next one, how can you find the absolute maximum, absolute minimum? We have one good method, the closed interval method. This is like a definition of maximum and minimum values. The definition. The T is the domain of F. The C is a number in D. The first definition. The function f has an absolute maximum at C if f of c is greater than or equal to f of x for all x in D. It's like absolute maximum. F has an absolute minimum at C if f of c is less than or equal to f of x for all x in D. Third one, f has a local maximum at C if f of c is greater than or equal to f of x when x is near C. The first one, f has a local minimum at C if f of c is less than or equal to f of x when x is near C. The fifth one, if f of c is a maximum or minimum, then f of c is called an extreme value. The one note, we can replace absolute by global, like a global maximum, global minimum. You can replace local by relative, like a relative maximum, the relative minimum. Like this. I'm going to give the one example here. Graph is given. Could you let me know at which point of x has the absolute maximum? What is x value for absolute maximum value? What do you think? What is x? We have these x values here. The A, B, C, D, E. Like this. What's that? Yeah, this is highest point. This is a whole function value. Highest point is absolute maximum. Like D. What is absolute minimum at x? What's x value for finding absolute minimum? What's that? Could you write your answer on the chatting board? The absolute minimum is like a smallest value. Yes. So we have A because this value is smallest one. So all other values above y equals to f of A. So it's A. Do we have a local maximum values at x? What's x values? For local maximum values. What's x values? So what do you think? The local maximum is could you run your answer? What is x values for local maximum? The B and D, is it right? Yes, here you can cut locally. This one is very locally. This is the highest value, highest point locally. Locally we have B. One more, yes, D. The locally highest point at D. How about this one? I can write one more thing. This point is like L. How about the L? We have a local maximum at L. What do you think? Yes or no? Could you write your answer? Do we have a local maximum at L? What do you think? Is it right? Is it right? Yes or no? What do you think? No, no, no. Here, what does it mean? The local maximum. Always cut left-hand side, cut right-hand side. This value is locally highest point on the left-hand side, but what happens to the right-hand side? The right-hand side, we don't have a function value, so we cannot compare the function value f of L with other function values on the right-hand side. So you cannot compare. So we don't have a local maximum at endpoints. You have to ignore endpoints, only P and D. The local minimum value, very similar. What is the answer? So could you write new answer of the last question? What is the x value for local minimum? ACE, is right, ACE. Here, the C is right. This one, cut like this, locally lowest point. You can cut like this, these values, locally lowest point. It's good. But what's A? You can cut left-hand side, yes, locally low point. But what's like left-hand side? We don't have a function value. So we don't have a function value on the left-hand side, so we cannot compare function value f of a with other function values on left-hand side. So what does it mean? No, so we don't have a local minimum at A, just C and E. So really be careful. This one remarks. In order to find absolute maximum, absolute minimum, include endpoints. Here is right. The right endpoint, so left endpoint, we have absolute minimum. It's good, no problem. But in order to find local maximum, local minimum, the exclude endpoint. We don't include endpoints. Just find local maximum, local minimum. So really be careful, this kind of things. Here, we think about absolute maximum at x values, the absolute minimum. At x values. What's your first question? What's like x value for finding absolute maximum? The which one? The which one is highest point? What do you think? The which one is the highest point? Yes, 11 is the highest point. It's good. What's like lowest point? Yep, here, -1, yes, lowest point. The next, you can find local maximum, local minimum. This one. So let me see. Don't think about endpoint. So if you want to find local maximum, local minimum, always exclude endpoint. You can just start to 0. Call like this, not highest, not lowest, nothing. What happens 1 here? Local maximum, local minimum. What's that? Locally, local maximum or local minimum? What's that? Add 1. Local maximum, local minimum. Yes, locally highest point, local maximum at 1. What is 2? Local maximum, local minimum, or neither? So what is your answer? Neither? Local minimum? Here, you can cut locally. You can compare all function values. Yes, locally lowest point, locally lowest point. We have local minimum. What happens to 3? Local maximum, local minimum, or neither? What happened to 3? Local maximum is right? Yes, you can call locally like this. This point is the locally highest point. Yes, local maximum at 3. What is 4? Local maximum, local minimum, or neither? Local minimum? You think about it. Call like this. Is a function value local minimum? No. Here, lowest point, not local minimum. No. Not local minimum. Local maximum? No. Here. Highest point is here. So nothing. Neither. Yeah, neither. The neither. What's your 5? The local maximum, local minimum, or neither? What's your 5? What do you think? So what is your answer? What's your 5? Answer is neither. Is right? Neither? Yes, you answered right. Here, this is, we don't have a function value at 5. We don't have a function value of 5. Neither, nothing. What's the 6? Same, neither. We don't have a function value. What's the 7? Local maximum, local minimum, or neither? What is your answer? At 7. Local maximum. You can call like this. Yes, this is a function value. Other function values here, the locally highest point, 7. What is 8? Here, call like this. Yes, local minimum, lowest point. Compare with other points, the lowest point, the 8, local minimum. What's 9? What's 9? Local maximum, local minimum, or neither? What is your answer? Yeah, neither. This is a function value, not lowest point, not highest point. This is the reason, neither. The neither. What is 10? Yes, this is locally lowest point, local minimum at 10. What's 11? Yes, locally highest point, 11. What is 12? Neither? Neither? I don't think so. Here, the very small interval, the like this, cut like this. Yeah, locally highest point. You can compare with this function value, locally highest point. We have local maximum. So that's it. This is the whole idea for solving this problem. Like this. The next is x squared plus 1. You can think about this one. Do we have a local minimum? What do you think? You can just sketch the graph, you think about it. Do we have a lowest point? So do we have an absolute minimum in this problem? Do we have absolute minimum? F of x equals x squared plus 1, absolute minimum? What do you think? Do we have absolute minimum? Yes. Why? You can sketch the graph. This is x squared plus 1. Do we have absolute maximum? No, because this graph is going to the positive infinity. Here is going to the positive infinity. So we don't have absolute maximum, but we have absolute minimum here. Absolute minimum is function value 1 is right. This 1 exactly f of 0. The function value 1, always y value is like absolute minimum. Do you have a local maximum? What do you think? Do you have a local maximum? Do you have a locally highest point? Do you have a locally highest point? What do you think? No, we don't have it. We don't have a locally highest point. Do you have a local minimum? Do you have a local minimum? Okay, what is the answer? What is the local minimum? Is it 1? You're right. Here, you can cut locally, like this. This one, the locally lowest point function value is 1. Yes, 1. You see, is f of 0. Like this. I'm gonna give domain. Domain is from -1 to 2. Graph is like this. Do you have absolute maximum? Do you have it? Absolute maximum? Yes or no? What do you think? Do you have absolute maximum? Yes. What is absolute maximum? So what is absolute maximum? Yes, you can plug 2 into here. 2 square plus 1 is, yes, exactly 5. The 5 is absolute maximum. Absolute minimum, same, 1. The local maximum, no, we don't have it. So you want to find local maximum, local minimum. So you have to exclude endpoint. We don't have it. Was it like a local minimum? The same. That is 0.1. So we can use this one. Interval is different. Minus 2 to 2. So like this. Do we have absolute maximum? Do we have it absolute maximum? Like highest point? Do we have it? Yes, no? Yes, no? Yes. Here. The what is like absolute maximum? Y value. You can call the like this. Y value. 5. All function values below 5. So we have, yes, 5. What's the x values? We have 2x values. 2x values, what's that? F of 2 and f of minus 2. It doesn't matter. We have many x values. There's no problem for finding absolute maximum. Just one y value. Only one y value. Yes. Absolute maximum. Absolute minimum, yes, 1 here, 1, the same. Local maximum, no. So we don't deal with the local maximum at endpoints. Local minimum, 1 again, here, lowest point, the same to the absolute minimum. The next example, f of x equals cosine of x. I can sketch the graph. Graphs like this. The maximum value is 1, minimum value is minus 1, like this. So what is absolute maximum of cosine of x? Do we have absolute maximum of cosine of x? Yes or no? Do we have absolute maximum of cosine? Yes. What is answer? Answer is yes, 1. Always here, all graphs below 1. Here, below 1, below 1. Absolute maximum is 1. Do you have absolute minimum? Yes, minus 1, you're right. The here, this is minus 1. All graphs on the y equals to minus 1. The minus 1 is absolute minimum. Do you have a local maximum? What's the local maximum? Do you have it? Local maximum? Yes. What is your answer? Local maximum is? What is the local maximum? Could you write your answer on the chatting board? What is the local maximum? Local maximum is? No. The local maximum, local minimum, absolute maximum, absolute minimums are y values, not x values here. Yes, go to 1, answer is 1. You're right, yes. Here, this portion, only this one, locally highest point, y value is 1. The locally highest point here, y value is 1. Locally highest point here, yes, y value is 1. Locally highest point here, always 1. Local maximum is 1. Different x value, but same y value in this problem. The local minimum, similar, minus 1 here. Locally lowest point, y value is minus 1. Locally lowest point, y value is minus 1. Locally lowest point, that is minus 1. So we have minus 1. F of x equals x cubed. Graph is like this. Do we have absolute maximum? Do we have it? Absolute maximum? No, because graph is going to positive infinity. So we don't have a finite function value. No. Do you have absolute minimum? Similarly, no, because graph is going down. Graph infinity, so we don't have it. Do you have a local maximum? What do you think? Do you have a local maximum? Do we have it? Similarly, no. So we don't have any locally highest point. Local minimum? No, we don't have a locally lowest point. F of x equals to 5, like a horizontal line. Do we have absolute maximum? Do we have a absolute maximum? Yes or no? What do you think? So what is your answer? Do we have absolute maximum? So could you write your answer on the chatting board, please? So what is your answer? Yes? Okay. How about other students? No? No? Answer is yes, 5. Because what's that? 5 is always, yes, less than or equal to 5, absolute maximum. Also, absolute minimum, 5 is less than or equal to 5, yes, 5 is the absolute minimum. Local maximum, 5. Local minimum, 5. Just only the trivial case, the origin 5. The question. So what conditions of a function f guarantee that f has an absolute maximum and absolute minimum? So what kind of conditions? So here, we think about it. The graph f of x is given. We have absolute maximum, absolute minimum, right? What does it mean? Absolute maximum at C, absolute minimum at D. Here, absolute maximum at C, absolute minimum at B, D, sorry, B, D, A, C, D, D is the same, yeah, B, D, it doesn't matter. The B, D, like this. Here, we don't have absolute maximum because, so this is opened. This is opened. We don't have absolute maximum. So we have absolute minimum at 2 here, lowest point, 2. F is discontinuous at 1. Here, no absolute maximum, going to positive infinity. No absolute minimum, we have whole, the no function value. The domain is open interval. So could you find some condition? What conditions of function f guarantee that f has an absolute maximum, absolute minimum? Just what? Continuous function. Interval is closed interval, a, b, like this. In this case, f is what? Discontinuous, we cannot guarantee. Sometimes the maximum value does not exist. Sometimes minimum value does not exist. Domain is open interval like this. We don't have absolute maximum, though we don't have absolute minimum. So sometimes they're like this. We cannot guarantee. So we have two conditions. Graph is well connected, like continuous. The domain is the closed interval. We always guarantee that f has absolute maximum, absolute minimum. So like this. So we need this condition. Function f is continuous on closed interval AB. So we have extreme value theorem. So what's that? Extreme value theorem is like this. If the function f is continuous on a closed interval AB, then f attains an absolute maximum value f of C and absolute minimum value f of D. The some numbers C and D in closed interval AB. Sometimes the between A and B, sometimes endpoints from the previous examples, right? Previous like graphs, the very clear, like this. It's very clear, like this. We have it. The question: how to find the extreme value? What's the extreme value? The maximum or minimum. Maximum or minimum, we call extreme value. So this is one good idea. Here, local maximum at C, right? So we can assume that f is differentiable. What is f prime of C? What's that? Do you know? This is like a blue graph is f. What is f prime of C? Yes, 0. We have horizontal tangent line. So what's f prime of D? This is also 0, horizontal tangent line. So we have one good theorem. if f has here local maximum, local minimum, and f prime c exists, f prime c is always 0. This is like a good example. The good example we call Fermat's theorem. That's good. This is Fermat's theorem. Here, what do you think the converse one is true or false? The converse one. If f prime of c equal to 0, then f has a local maximum or local minimum at c. This statement is true or false? What do you think? Could you write your answer? The statement is true or false? What do you think? Could you write new answer on the chatting board, please? What is your answer? True or false? The statement. The first derivative equal to 0, then f has a local maximum or local minimum at c. This statement is true or false? What do you think? The true? Unfortunately, false. The why? We have a counter example. F of x equals x cubed. Graph is like this. What's like f prime of x? F prime of x is x cubed prime 3x squared. You plug 0 into x, the 3 times 0 squared is 0. So, however, f does not have any local maximum, any local minimum at c. Here, nothing, but we have horizontal tangent line at 0. So, false. Really be careful. This is false. One more statement. If f prime of c does not exist, then f does not have a local extreme value. What's like extreme value? Maximum or minimum. The maximum or minimum. What do you think? Could you write your answer? This is statement true or false? What do you think? This is true or false? What is your answer? What is your answer? True or false? 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 Okay. Do we have like a counter example? The example is like this one. F prime of c does not exist, but f has local maximum or local minimum. Do you have this kind of example? Do you have it? What is your explanation? Your statements are false. How can you explain? One good example is this one. This is false. Counter example is f of x equals absolute value of x. Graphs like this. So what does it mean? F prime of 0 does not exist because corner. We have corner. F prime of 0 does not exist, but f has local minimum at 0, locally lowest point. So this statement is false. So really be careful. These are two kind of remarks. The next is from Fermat's theorem and the remarks. So what's that? F may have a local maximum or local minimum at C if the first derivative equal to 0 or does not exist. It's right. We have two possibilities from the previous examples. Like this. Here is right. The first derivative equal to 0. This one. Yes, local maximum, local minimum. The second case is last example. The f prime of 0 does not exist, but local maximum is right. We have two possibilities like this. We have like two possibilities. So we have one good definition for finding local maximum, local minimum. What's that? We call critical number. The critical number of f is c, such that c is in the domain of f. Second condition, either f prime of c equal to 0 or F prime of C does not exist, that we have a name that we call critical number. It's like critical number. We have two conditions. What's that? C is in the domain, the either the first derivative equal to 0 or does not exist. This is like a critical number. Here we have three problems. Find the critical numbers of f. F of x equals square root of x 1 minus the square root of x. F of x equals 1 over the square root of 1 minus x squared. F of x equals the absolute value of x squared minus 4. So we have these kind of things. So first one, f of x equals the square root of x times 1 minus root x. My question is find critical number. What's like step 1? You can calculate f prime first. Next, find c values. The first derivative equal to 0 or does not exist. The last step is check point is in the domain or not. You can check these kind of things. The first one, you can calculate f prime of x. So this is like how can you find the prime of x? First, you have to expand it better. The only distribute root x. Root x times 1 is square root of x. The root x times root x is just x. Next, take derivative here. The x 1 over 2 prime, the 1 over 2 times x to the 1 minus 1 over 2. X prime is just 1. We have 1 over, so I can write like this is better. This is 1 over 2 x to the, this is like a typo, sorry, not this one. We have 1 over 2 minus 1. It's like a typo. 1 over 2 negative 1 over 2 minus 1. So we have 1 over 2 times x to the 1 over 2, so like this, minus 1. That's right, so we have it. So next, I want to change this one to like one fraction with common denominator. The 1 and 2x to 1 half, common denominator is 2 times x to the 1 half. You can multiply 2 times x to the 1 half, 2 times x to the 1 half. So what's that? 1 minus 2 times x to the 1 half over 2 times x to the 1 half. So we have 1 minus 2 times root x over 2 root x. This is a prime of x. So how can you find the critical number? You can calculate f prime of x equal to 0 or f prime of x does not exist. Does not exist. You think about these two things. F prime of x equal to 0, what does it mean? Only numerator equal to 0. The numerator equal to 0 is 1 minus 2 root x equal to 0. F prime of x does not exist. The denominator equal to 0. 2 root x equal to 0. So here, what's that? You can add 2 root x to the both sides. 1 equals 2 root x. You can divide 2 root x equals 1 over 2. Next, square both sides. X is 1 over 4. Second one, so you can eliminate 2, it doesn't matter. The root x equal to 0 automatically inside 1 equal to 0. We have 2 possible answers. So this is like step 1. The second step, you can check the 1 over 4 and 0 are in the domain. How can you know that? You can plug 1 over 4 into original function. So you can check, plug 1 over 4, the root 1 over 4, 1 minus root 1 over 4, don't calculate. Well-defined, well-defined. It's good. This is well-defined in the domain. Plug 0, root 0, 1 minus root 0. Yes, well defined. The well defined. What does it mean? In the domain. Was it like a final answer? The final answer is like 0 and 1 over 4 are the critical numbers. Of function f. That's it. This is the whole idea for solving this kind of problem. This is the whole idea. So like this. Here. Yep. So like this. Second one. Similar. How can you do that? You can use the first derivative. What's like the best way? In this case, change like one. 1 over exponential form, change it to negative 1 over 2. So next you calculate f prime of x. What's that prime of x? The 1 minus x squared to the minus 1 over 2 prime. You can use chain rule. The minus 1 over 2 is outer function. The minus outer function prime is minus 1 over 2, 1 minus x squared to the negative 1 over 2 minus 1 times inner function 1 minus x squared prime. This is negative 1 over 2. The 1 minus x squared to the power negative 3 over 2 times. What is 1 minus x squared prime? Could you write your answer on the chatting board? What is 1 minus x squared prime? Could you write your answer on the chatting board? The positive 2x or negative 2x? What do you think? The positive 2x, yeah. Okay. Answer is negative 2x. Is right? 1 prime 0, negative x squared is negative 2x. So 2 is crossed out. Change it positive here, like this. So what's like a numerator? Only x. So change to the positive exponent. So 1 minus x squared to the 3 over 2. So you solve, what's that? Either one. F prime of x equal to 0. Or f prime of x does not exist. Not exist. The first one, only numerator equal to 0. That's it. Second one, the denominator equal to 0. Just denominator equal to 0. The 1 minus x squared to the power 3 over 2 equal to 0. What happens? Only inside 1 equal to 0. 1 minus x squared equal to 0. So you can add the x squared to the both sides. X squared equals 1. So what is x? Could you write your answer on the chatting board? What is x? So what is x? So could you write your answer on the chatting board? So what is x? 1, 1. That's it. 1. Is it right? Yes, 1 and minus 1. So really be careful. This is like even power always have it. 2 numbers, 1 and minus 1. Is right? We have 3 possible numbers. 0, 1, negative 1. We have 3 possible numbers. So which one is exact critical number? How can you know that? Was it like a first condition? The 0 is in the domain or not. The 1 is in the domain or not. The minus 1 is in the domain or not. You can check. The function values is well defined or not. You plug 0 into original function f of x here. So f of 0 is 1 over square root of 1 minus 0 square. Yes, well defined. It's good. In the domain. You can plug 1 over square root of 1 minus 1 square is 1 over 0. What's 1 over 0? What's 1 over 0? What's 1 over 0? Do you know 1 over 0? What's 1 over 0? Yes, it does not exist, undefined. You can plug minus 1 over square root of 1 minus negative 1 square. The negative 1 square is 1. 1 minus 1 is 0 again. 1 over 0, undefined. So, what is a critical number? Only well-defined number, only 0. So, final answer is next one. The 0 is the critical number, only one number. The critical number. That's it. This is the whole idea for solving the second problem B. So like this. Next one, C. What's that? Do you know f prime? Do you know f prime from here? Do you know f prime? Do you know f prime? With the absolute value sign? Do you know? So we have absolute value sign, so we don't have a formula. What's the best way for solving this kind of problems? You can sketch the graph is better. So first, you can sketch the graph inside one, x squared minus 4. So we have y equals x squared minus 4. Ion factor. So like this, we have x-intercepts. What's like x-intercepts? So y equal to 0. You solve this one equal to 0. So we have 2 and negative 2. What's like a graph? The graph is here, the negative 2 and 2. The coefficient of x squared is positive number, open up like a parabola, passing through the minus 4 here, the minus 4. They're like a vertex going up like this. This is y equals x squared minus 4. What is the f of x? F of x equals, just take absolute value. What's it like a graph? Graph is like this. Same number, negative 2 and 2. The positive one, same. You have to keep same positive one, like this. What's the absolute value? You can change negative number to positive number, only reflect about x-axis. Graph is like this. Here, this one. Is it right? What's like the definition of a critical number? This one, or f prime of x does not exist. Is it right? First one, f prime of x equal to 0. What is x value from the graph? F prime of x equal to 0. What is x value from the graph? What is x? Do you have x value from the graph? So could you write your answer on the chatting board? The negative 2 and 2 is, you can just talk about later. Here, f prime of x equal to 0, only we have horizontal tangent line at 0. So x equal to 0. What's like the second one? We have corner at minus 22. We have corner. We have corner and negative 2 and 2. What does it mean? Not differentiable. Derivative does not exist. We have corner. So we have 2 and negative 2. So one more. This is always well connected. What does it mean? function value exists at 0 and 2n minus 2. So what's the final answer? We have -2, 0, and 2 are the critical numbers. The critical numbers of function f. So that's it. This is whole idea for solving number C. So like this. Yep. The next one. How can you find the absolute maximum, absolute minimum from the graph? I'm going to give some idea. How can you find the absolute maximum, the absolute minimum of a continuous function on a closed interval? So how can you find? I'm going to give some example here. What happens? Absolute maximum at C. Absolute minimum at B. What's like C and B? The C is here. We have f prime of C equal to 0. C is in the domain, critical number. What's like B? The B is endpoint. Is right. We have absolute maximum and absolute minimum at critical number and endpoint. This is like one idea. Second graph. So what happens? We have absolute maximum at C. Here, what's that? This is corner. So C is critical number. Because the f prime of C does not exist. It's right, like critical number. Was like absolute minimum at D. Was like D also critical number because corner f prime of D does not exist. The D is in the domain. Yeah. So what's that? From the second graph, we know this kind of things. We have absolute maximum and absolute minimum at two critical numbers. The last one, absolute maximum at A. Here, A is endpoint. Absolute minimum at B. B is endpoint. So, could you find the one idea for finding absolute maximum, absolute minimum? What is the idea? We have only two possibilities for finding absolute maximum, absolute minimum of two conditions. What's that? The continuous function on a closed interval. What's that? Critical number or endpoint. Critical number, endpoint. That's it. We don't have more. Only two possibilities. Critical number or endpoint. So this is one idea. What's like idea? So this is like one important thing. F must have the absolute maximum, absolute minimum at critical numbers or endpoints. The method for finding absolute maximum, absolute minimum. So we know that a continuous function on a closed interval, we have two conditions. What's that? Continuous function on a closed interval. Interval is only include endpoint like this. AB has the absolute maximum, absolute minimum at critical number or endpoint. We can follow these steps. The closed interval method, what's that? To find the absolute maximum, absolute minimum values of a continuous function f on a closed interval AB. Step 1, find the values of f at the critical numbers of f in open interval AB. Second step, find the values of f at the end points of the interval. What does it mean? You can calculate f of A and f of B. You can calculate these two function values at endpoint. The step 3, you can compare all function values from step 1 and step 2. The which function value is greatest one, which function value is smallest one. The largest of the values from step 1 and step 2 is the absolute maximum. The smallest of these values is the absolute minimum. That's it. This is the whole idea. We always follow 3 steps for finding absolute maximum, absolute minimum. We call the closed interval method. Closed interval method. The first one, find the absolute maximum and absolute minimum values of f of x equals x cubed negative 3x squared negative 9x plus 1 on the closed interval 0, 4. Step 1, find critical number first, the unit derivative. F prime of x is x cubed negative 3x squared minus 9x plus 1 prime. So x cubed prime is 3x squared, x squared prime is 2x, 2x times negative 3 is negative 6x, the negative 9x prime is, x prime is just 1, minus 9, 1 prime equal to 0. So we have the like this. So next, factor out 3, the 3, x squared negative 2x minus 3, the factor more, the x minus 3 times x plus 1. So you just solve f prime of x equal to 0. The 3x minus 3x plus 1 equal to 0. We have 2 answers. X equal to 3 from this one. First one equal to 0, we have 3. X plus 1 equal to 0, we have minus 1. F prime of x does not exist, we don't have it because this is always well defined, right? So you can plug any number into x. The f prime of x is always well defined, we don't have it. Any number from the second concept. The one more. The which one is critical number? 3, minus 1, or both? What is your answer? Could you run your answer on the chatting board? The which one is the critical number? 3, minus 1, or both? So what is your answer? Could you write your answer on the chatting board? The both? Only 3? 3? So let me see. What's the domain? Domain is 0 to 4. This is domain. So minus 1 is not in the domain. Only choose 3. Because minus 1 is not in the domain. Domain is 0, 4. Like domain is only 0, 4. Only positive numbers, right? So you calculate f of 3. You plug 3 into here, original function. You plug 3 into here. The 3 cubed negative 3 times 3 squared minus 9 times 3 plus 1. The 3 cubed minus 3 times 3 squared is cancelled. The remaining part is negative 27 plus 1 is negative 26. So we have it. Step 2, you need to find function values at endpoints, 0 and 4. You can calculate f of 0. You plug 0 into x. 0 cubed negative 3 times 0 squared minus 9 times 0 plus 1 is just 1. You plug 4 into here. The 4 cubed negative 3 times 4 squared minus 9 times 4. What's like 4 cubed? 64. 4 squared is 16. 16 times 3 is 48. The 36 plus 1. You have to simplify. We have negative 19. Have negative 19. Like this. Step 3. So what is absolute maximum? What's that? What is absolute maximum? Could you write your answer on the chatting board? The 1 is right? 1, 1, 1. Yes, only compare function values. Negative 26, 1, minus 19. The maximum value is 1. Yes, f of 0. Absolute minimum is similar. We have 3 function values. The smallest value is negative 26, the f of 3. So that's it. This is the whole idea for finding absolute maximum, absolute minimum. I can talk about these kind of things. How can you find maximum, minimum values from the graph? You have to know these kind of things. The next, what is critical number? The next, we have the method for finding absolute maximum, absolute minimum of continuous function on the closed interval. So I can talk about these kind of things in section 3.1. Okay, so this is all for today's lecture. So if you have any question, any trouble, please write your question on the chatting board. I will do my best to explain. So if you don't have more question, you can leave a live session. So thank you for attending my class. So I very appreciate. Okay, I'm waiting for your question, anything. Okay, you're welcome. So you're welcome. Okay.